Hello everyone and welcome to our first session in data science languages. We're starting off with the first bit, which is kind of a little bit of an overview of the course, and then we'll jump into the actual content. So I thought I would start off by sharing kind of a little bit of a hint on how to get going. Right. So bear with me one moment. I had it up on the screen and I made it go away. So here we are. So my screen looks a little bit different than yours perhaps because I'm in the student view. So the little bar up at the top is duplicated. But ignoring that, and maybe I can close. Oh, nope, that didn't work. So I have to go back in. Sorry, I was trying to make it go away. So we're going into the student view, so it looks like what yours looks like. Mostly. So the basic thing, the very first thing, and some of you already done this, is you want to do your learning plan. That's the very first thing you want to do. And it's essentially go in and kick it off. There's no risk here, right? 0 points. But basically the idea here is to ask some questions of, okay, which one of these things will help you be successful, and select all of them that apply. So was it the flexible deadlines, the fact that it's career-focused skills, and so on. So this is the very first thing. Whenever you do that, you have to click on submit and say yes, you want to do this. And then once you do that, then you kind of open up the gate so that you can start doing other things. So that's the very first thing to do. Then the other elements here to pay attention to inside of the course room, obviously the countdown up at the top, that's important. Seems like a lot of time, 71 days, right? It'll go really fast. So don't dally. It's always a good idea to try to do roughly a module a week. That's not a bad metric. If you can go faster, go faster. If you take a little longer, that's fine. But you have to start early. Don't put this off, because while this is very much a competency-based educational class, there are still things that got to get done, right? So even somebody that is skilled in the art, that is a data scientist by trade, would find it kind of challenging to get all this stuff done in a day or two, not to mention there's turnaround for grading and so on. So do yourself a favor, don't get behind. And sadly, I've seen it happen before. It's disappointing to me, but I try the best to help students succeed. Sometimes you can't necessarily get it going. So the next thing to kind of look into here is you've got the live classroom assignments. That's where you go in and essentially get credit for suffering through this experience. So once you've watched the live classroom assignment, you'll go into here. You'll say, oh yeah, I saw the one for module 1. Go in, you'll do the test, view the assessment. It's basically going to ask you, did you do it? And you say yes, and you get 10 points. So pretty easy to do. And then you can tell me after attending it, what questions do you have? Feel free to put something in here because I actually read this stuff. So I do not understand how to install Python, right? So that might be something you might say. And then how do you think this competency may connect to the others in this course? And it's a foundation. That's at least the main thing you say. Hard to write a data science program without having a language and an environment to do so. So once you have watched them, you'll do this sort of thing, right? And so all of a sudden you've earned yourself a few points. The other kind of thing to go back in to take a look in is the course project assignments. These are the key deliverables that you'll be doing through the course over the time. There's 7 of them. They build on each other, and you start off with the first one, and we'll go ahead and take a look at it. The rubric, pretty important. You'll want to make sure you spend some time looking at the rubric, because I do. So the key thing is the series of criteria or criterion that are being used to measure you. Do read these over very carefully, because they will be what I do whenever I'm assessing your work. So there's some words in here typically around things like significantly more sophisticated program versus a hello world. So you want to do something more, this is slightly more sophisticated than hello world. And I'll show you a hello world here in a moment. It's not terribly interesting. You might do something like converting to Fahrenheit to Celsius. To get to the mastery, you need to do something more complex than Fahrenheit to Celsius. And we'll talk about that in a little bit as some potential places for you to go get some ideas. And bearing in mind the things that I show you, make sure if you do the approaches that I showed, that you do things like provide documentation of where you got the inspiration from. It's always a great idea. And so on, the next one here is around things like installing some libraries into R and doing some plotting, and significantly more sophisticated. That's the key phrase, graphs. So basically, to get to here, to the mastery level, you've got to make sure that you cover off the ones below it, right? So that's the basic pattern. I'm not necessarily going to drain this entire thing, but do make sure that you're looking at this, because I will be using this to grade with. So it is the secret decoder ring, if you will, of how your grade will be determined. So make sure that you spend some time looking through that. The order here is perhaps a little bit kind of, you do want to start with getting started. Take a look through all that. It's laid out pretty much the same as any other CBE course that you might have taken. So if it's your first, definitely spend some time looking through them, or if you need some additional information. Things are, as I mentioned, the modules and the deliverables roughly coincide with each other. They align nicely. Module 1 is essentially getting you prepared to do deliverable 1, and so on. The difference being, when you get up to deliverable 7, you'll notice there is no module 7. We stop at module 6. Module 7 is essentially the culmination of, deliverable 7 is the culmination of the things that you learned in those first 6 modules. You're pulling it all together. Sometimes you can actually reuse large portions of the work you've done earlier, so keep that all in mind. Always a good idea to look through some of these things rather than just following it sequentially. So you might want to take some time, look through kind of what each one of the modules is about, and you might find something useful, such as, I would view something that you might do as the assignment for deliverable 2, which is around essentially loading, I believe, some data into a data frame and doing some work with it, or maybe looking ahead to deliverable 3, is certainly being more complex than Fahrenheit to Celsius. So you might be able to do something for deliverable 2 that helps you for deliverable 1. Just an idea. Feel free to go in there and take a look at it. When you look at the modules, they're laid out pretty much kind of fairly consistently. The introduction I'll go through here in a moment, but it kind of outlines what's the point of what it is you're trying to accomplish. There is this live classroom recordings is where you're seeing this, because I don't believe anybody joined live. So if you're watching me, you found this, or you saw it in the announcement that I also posted. But this is where they'll go. Each one of the modules has the recordings nested underneath of them. This is a bit of a departure from how we used to do it, but it's not a bad way, because it helps you find the things you're looking for. The multimedia content is something that is supplied by the course designers. It outlines the various concepts that you need to do. It's a fairly short video. It's worth the time to watch. They are fairly useful. Then we deal into some additional content, things like what are Python packages. These are going to correspond pretty closely to the things I talk about. That being said, it's definitely worth your time to do some reading through these sections, because they are quite useful. Sometimes there are example code files at the end, not always, but you can certainly take this code and type it into your various environments, so you can kind of play along at home, so to speak. And so that's the basic idea of the courses. And so with that, oh yeah, also, it's kind of hidden here, but underneath books and tools is where things like your syllabus is. So to me, I would personally like it to be a lot more front and center, but that's where it is. And once you get to know that's where it is, then that's where you need to go. Do take a look at the syllabus, although you'll find that it's probably fairly consistent with most of the syllabus that you've seen in other courses. The deliverables 1 through 6 are 11% of your grade for a total of 66. And then the comprehensive deliverable is the remaining 28%, and you get 6% for doing those live quizzes or so on. So you could get a 94 in this course without watching one of these. Could happen, may not. Also, as a general sort of housekeeping and practice sort of thing, if you have any questions about stuff as we're going, if I breeze by something too quickly, call me out on it. Tell me, hey, what'd you say there? Because you talked really fast, or you mumbled, or it broke up. So If there's a concept you're struggling with, some sort of element that maybe I'm not giving sufficient treatment, let me know. I want you to be successful. One way that we can make sure that happens is by ensuring that you ask me questions. So our agenda, I've already kind of started through things, a little bit of background, but then we're going to talk a bit about Module 1 and Deliverable 1 in greater detail. So Module 1 is about setting up an analytics environment. As I've mentioned before, it's kind of hard to do analytics without having an analytics environment. The two languages in this course that we'll be focusing on is Python and R. Python probably much more popular today than R. R has a lot of significance historically. It's potentially a little bit easier to use. It definitely is better in a lot of ways for graphics. But they are the two, at this point, most commonly used languages. The other language that would kind of maybe make it into that list, maybe two or three of them, SAS would probably come into that, although again, less than it once did. Python is kind of taken over because it's like free and fairly easy to use, and there's lots of good examples that you can pull together and get to work without maybe even understanding some of them. But the emerging languages, which I would like to talk about, but I don't know that I'll have time to, are going to be things like Rust and Go. Pretty cool languages. To me, Rust addresses some of the ugliness about Python. Also, Deliverable 1, we'll talk about those items in detail. So, Module 1, jumping straight in, is around setting up an analytics environment, and it helps if I hit the right keys. So I was wondering why we were going backwards. So, Python. The basic, the simplest way to do Python is to use Anaconda. There's probably other ways to do it, but that's the one I'll show you about. Anaconda also has things involved as far as the concept of using Jupyter notebooks. I strongly recommend you use Jupyter. You don't have to. You can write code in whatever. You can use PyCharm if you're so inclined. I'm a big fan of the code, run, evaluate, repeat process that Jupyter enables. We'll talk a little bit about packages, how you install them. The two different ways you do that within Python are pip and conda. There's probably even more, but those are the two we'll talk about. So when we start off with Anaconda, you go to anaconda.org. I should fix that because it's not anaconda.com, anaconda.org. So to make this a smidge more interesting, as soon as I find the right window, we'll do this real time. And so I'll try to give some, there it is, guidance on how to do this. So starting off with Anaconda, what you're looking at is a remote desktop, essentially a connection to a virtual computer in Azure, so that it's primarily so that you don't see all the clutter that's on mine, basically. So to get here, if you start off at anaconda.org, and then you end up here pretty quickly. So just to show that, or you can just type in that URL yourself, anaconda.com/products/individual, and you'll land on this page. And it basically will do enough inspection to say, hey, it looks like you're running Windows, and if you want to install Windows, this is what you do. So we go ahead and click on download. Starts off the process down here of downloading the Anaconda package or the installer. Once it finishes, you'll launch it. You don't want to buy anything. We're using this for educational purposes, so you can safely ignore their pleas for money. So then now we kick off the installer, and to make it to where it's a little clearer what's going on, and hopefully this is pretty clear. Let me switch and make sure it's coming across. One moment. And here, yep, we're working good. All right, so the basic approach is you kick off the installer, and it's going to walk you through a typical sort of installation process. Probably not your first time installing software. You do want to make sure that you're installing the 64-bit version of Anaconda. You'll want to review the license agreement, and when you do agree, you have a choice here of installing it just for yourself or for everybody on the computer. Most of the time, you just want to do it for yourself. You can do it for all users, but doing so is going to require you to have administrative privileges on your computer. Not a huge deal most of the time, but it is going to pop up a dialog saying, hey, do you really want to do this? So we'll do it just for me because they do say it's recommended. As far as the installation location, the default is typically fine. So it's in the user's location of the user that's logged onto the computer. Generally speaking, you can just click through this stuff. You do want to typically register Anaconda 3 as your Python 3 instance. Don't probably want to add it to the path. This is a clean install in this case, so it really doesn't matter a whole lot. So at this point, it's running through, it's doing its magic, and it's installing Anaconda, which is, Anaconda is basically a framework or environment that makes it really easy to distribute and install, especially data science-oriented stuff, right? So at this point, it's working on it. It's most likely creating a system restore point. So while it's doing that, I'll go ahead and shift back and talk about the process. So while it's doing that, once I click into the right spot. Right. So this is basically what I said. You start off with, go to anaconda.com, anaconda.org will get you to the same place. Products individual, and then you want to do the download. Make sure you don't buy anything. It should be free. If you think it's wanting money from you, you're probably not in the right spot. So make sure you're getting it for free. Then you'll run the installer, click next, just me, yes, 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 kind of thing, just like what I did. It'll do its magic, and once it's done, we'll see it installed here. And then we'll talk about how you can verify it from a command line by typing the Python command and so on. And then we'll also verify Jupyter. So let me switch back and see. It's still working on it. So we'll keep going. Python is the language that we're using. And so the other component that you'll hear me talk a fair amount is Jupyter and Jupyter Notebooks. Jupyter Notebooks, as you can see on the screen, it's a web-based application. I'll show it to you here in a moment once it finishes doing its thing. And what it allows you to do is, through a fairly easy-to-use UI, create notebooks of various languages. The default is Python. I'll show you how you can do it for R as well. And practically most of the demos you'll be seeing from me will have it inside of R, inside of Jupyter, because RStudio, it's good. It's a good place to start. Pretty quickly, I find myself wanting a consistent user experience, and that's what Jupyter brings. So once you create a new folder, you can switch into it, add a notebook to it, and then you have to give that notebook a name. But the basic idea here is that you can write your code directly into that notebook cell and then run it and see the results. So that 3.0 that's showing up below is the result of the print statement at the end of that. So I typed it in some code. I held down Shift and Enter to tell the environment that I wanted to run that line of code, and that was the results that were returned. So we'll go ahead and take a quick peek back here, and we're still working. All right. So moving on to some of the next stuff. Inside of Jupyter, you have this concept of a cell. A cell is that little box that I typed in on the screen. And inside of it, you can have different kind of stuff. The two main things to know about are code and Markdown. Code is kind of like what the name says. It's source code. And Markdown is something kind of like HTML, but a whole lot simpler. And what it allows you to do is make things that look really pretty inside of a notebook, so that you're not, you can basically have something that looks an awful lot like a report that includes code that is updated as you run the notebook, so that it is the most recent information. So it's kind of a blending between what we traditionally would do as source code and the report that we might produce at the end of that analytics. So that's the concept of a cell. You can switch the type of cell by selecting the cell so that it's got the little line around it, and then switching up in the upper right hand corner from code to whatever you want it to be, or back to code. When we talk about Python libraries, a library is what you would kind of think of them as. You've probably seen this in other programming languages. If you're new to programming, then it's a way of doing reuse and using stuff that somebody else did without having to write it all yourself. And the idea there is that you can be more productive if you can use other people's efforts, and so you don't have to write everything from scratch. An example would be if you were doing string manipulation and you wanted to add two strings together, you could write the code that did that yourself, or you might have somebody else that has a library out there that does it. Take that to the next order. Maybe somebody has a classifier out there that give it some data and it tells you produces maybe a decision tree that helps classify the data based upon the criteria that you supplied. That's very useful and saves you a whole lot of time. Sure, you could write your own, but it's going to take you a lot of time, may have some errors in it that you have to fix, and it hasn't been used by thousands to millions of people, right? So those are the basic idea. Whenever you go to install them, there's two kind of ways you can do it. One is using Anaconda, and the other is using pip. Pip is going to be kind of universal in nature. Anybody that has Python installed has the ability to do pip. Anaconda has a set of things either from a command line, a navigator, or a notebook that makes it a bit easier, but it's only going to work if somebody's using Anaconda. So those are kind of the two distinctions. And there's a blending there that you can do both Python or the pip and the Anaconda versions from inside of a notebook or at a command line. And if you do those, again, the wrong key. So if you do that inside of a command prompt, you type in the word, if you're using Anaconda's approach, conda install and the library name. So an example would be conda install matplotlib. And what that'll do is go out, find the library of interest to you, and download it into your currently active environment. We'll talk about environments later on, but an environment's basically just a directory that you use for a particular type of problem or purpose. And you can have multiple environments that you switch between so that you don't have everything installed everywhere. You only need what you need in a particular environment. So you can do it inside of having opened up an Anaconda prompt, type in conda install matplotlib. Another way that you can do it is using the Anaconda Navigator. If you go into the Start menu, take a look after we've installed Anaconda, you'll see Navigator. Inside of the Navigator prompt, you have the ability to click on the left side there and where it says Environments, and switch to the your active environment will be the one selected in this what you see on the screen. There's only one environment, which is base. That is the environment that is created when you do your base installation. You can create other environments, as I mentioned earlier, and inside of that you can then pick what version of the libraries you want to install, and go and either select the packages that have been installed, or all of the packages, or the packages that haven't been installed, and then you can search for them based upon a string. As you can see there, Anaconda knows that matplotlib 3.2.2 is installed in this situation. So that's the basic idea of using the Anaconda Navigator. It's an easy way to do it. It's not bad. There's other ways as well. We'll talk about them later on, that as you get more mature, you'll find yourself shifting away from mature in the experience of programming inside of these environments, not a maturity thing in general, but you'll find yourself moving to things that are quicker, faster, and take less key sequences. And generally speaking, that's not using a UI. So you'll probably have it either inside of a notebook or inside of something in a command line sort of environment. So another way you can do this is called the conda install matplotlib inside of Anaconda, or inside of a Jupyter notebook. So you basically type that in, do shift enter, and you can see there, if that's it's got to be the only thing that's in that cell. That's one little trick, and you can only do one of them at a time. So if you want to install 5 things, you need 5 cells with conda install on each one of the 5 things spread out. Then a similar approach is to use pip. And pip is almost exactly the same as conda from a command line. So it's pip install and the name of the library. Capitalization doesn't matter in most in Windows certainly. Linux is probably going to be lowercase pip. So pip install matplotlib. It goes out and takes a look and see if it's there, and it tells you, yeah, it looks like it's already installed. So that's a way. And again, you're opening up a conda prompt and typing in the statement pip install matplotlib. You can also do the same thing inside of a notebook. Again, almost the same syntax as the conda install matplotlib, just pip instead. When you run that cell, it does the same basic thing that it does whenever you run it at a command line. So switching back, and hopefully it'll be finished soon. And believe it or not, it's not actually a wimpy machine. So, oh, it is finished. There we go. All right. If you leave these checked, it'll pop open some windows. It's fine. We'll go ahead and do that. And it's basically going to tell you about welcome to Anaconda and talk about something they want you to get registered for on their website and so on. So now we can verify that it actually has installed. So I'm looking here at the Start menu. Go down and Start. And you'll see now there's a section called Anaconda. That wasn't here before because this was a clean environment. So the first thing to do is probably open up an Anaconda prompt and see that it was really installed. So that you do that by saying Python and then version with 2 dashes. Excuse me. And you can see that it says Python 3.8.8 was installed. We also talked about doing pip install matplotlib. And it's doing its thing and it's saying, hey, it looks like it's already here, right? So we can tell that Python is set up, and we just saw that one of the libraries that you're probably going to need to use is already installed. To go ahead and take a look at the Jupyter Notebooks, you can go back into this Anaconda environment, and they actually register it for you on the default environment so that you can say Jupyter Notebook Anaconda. Go ahead and click that, and it'll open it up inside of the current directory. And you can see here it's starting us inside of the users folder. And so if we want to create something, let's see if there's anything interesting in Anaconda. I don't think there is. That actually is Anaconda. So suppose we create a folder, and we'll call that folder, it creates it with the name of untitled, right? So you have to go in and do the rename. It's kind of one of the weird sort of patterns, but it's consistent at least. So you always have to do this. And we'll call this data science, right? And created it. And then we can click on it to go into it. So now we're inside of it. You can go in here, say click new, and then you say new notebook up here at the top and say Python. And we've opened up a new notebook. Again, comes in without a name. And if you take a look over inside of here, you can see it says untitled, right? So the easiest way to change the name is do what I just did. Click on the name and then say module 1. And so we can now see we're up and running inside of it. And if we want to say pip install matplotlib and run it, it'll do its thing and come back and say, hey, it's already installed. So this is basically a Jupyter Notebook. Again, this is a cell. You can do things like put in a £sign for a heading and say this is heading 1. Switch this to Markdown and then do a Shift Enter here to evaluate it, and you can see it turns it into something a little prettier. You can also have the results of your graphs show up inside of this environment as well. I'll show you that in a little bit as well. So at this point, we've installed Python. What you would be doing on your assignment as a deliverable is taking screenshots as you do all that stuff. So make sure before you start any of the installation process, as you do it, do some screenshots. If for some reason you already have it on your machine because you're a data scientist or whatever, just show me something that shows that it's been actively installed. So a screenshot of your environment running would be probably sufficient. So that is something you do kind of though need to document the process that you've been through, and we'll talk about that in a little bit. So now we can shift over and talk about R. So similar sort of process. R is a little more legacy is probably a good word than Python is. So it'll look a little bit different. So whenever we talk about R, there's a couple ways we can do it. The simplest way, I don't know if it's necessarily the best, but the simplest is to do so from inside of Anaconda. So we've already got Anaconda installed, and we can switch back to that. And I can open up what I mentioned is the Anaconda Navigator. And Anaconda Navigator is just a UI, relatively nice one, that makes it fairly easy to manage your environments. And so it's a valid way of doing the installation of R. And I'll show it here in a moment once it comes up. But the way that we'll probably want to do is the more traditional approach. I'll accept either one from a grading perspective. But if you go into it, and you can see here, this is the Anaconda Navigator that I told you about. Here's the environment that we're on. You can click over here if you want to see what other environments there are. In this case, there's only the one. But the key concept here is within a given environment, you can install lots of different software. So, and to go through it and talk about what environments are a little bit, because this may be interesting, I'm going to go ahead and create a new environment, and I'm going to call it R and Python. And I'm going to check this box down here that says Python packages are installed in that. And when I do what I just did there, at the point that you launch Jupyter inside of that environment, not the base environment, but the Python and R environment, you're able to create R notebooks. And I'll show you one of those in a little bit. Back on this this other screen while it's creating that, if you just click on install, it'll go through the process of installing RStudio and the corresponding R libraries for you. So that's one way to look at it. The more traditional approach is to do it by hand. So we'll talk about that, and then I'll go do it. So the easiest way is to do it a little different than what I have the order here. So you want to go out and do a R installation first. So you want to go to cran.r-project.org and then click on mirrors, and then go find a mirror and download R. R is basically just a command line sort of program. It's a very simple interpreter, and RStudio is a tool that uses it and runs on top of it, essentially spawns it off, sends it stuff, gets back results, and shows them to you. So you have to have R installed. They're not distributed together. You have to go out and install R separately if you do it this way. So you'll go out and you'll pick the installer that's appropriate for your platform, so Windows or Linux or Mac, and go through the process of selecting, click on that thing that says install R for the first time, download R 4.0.3 or whatever the current version will be, and then it'll put R onto your downloads folder. You'll run that, click through it saying pretty much yes, 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 so next, 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 and there's really no real reason to make any changes on it. So once you've installed R, then you'll go back here, and I need to fix the order I show you this stuff because I messed up the first time through, and download RStudio. RStudio is a nice little UI on top of R. It allows you to write code in a GUI sort of experience, and it's both of these are free. You don't buy anything, so those things that have a price on them, that's not the right thing. It's the leftmost one that says free. That's what you want to be doing. Then you'll select your operating system for this particular for RStudio. Then you'll download it, run it. Once it's finished, you'll kick it off, and it'll basically say select the RStudio you want to use. You probably want to use R64 because you want 64 bits. And if you did what I did the first time through and don't install R first, it'll say, hey, there's no R here. You need to go get it. So if you say yes, it'll pop you here, pick a mirror, and go through the same process. But if you plan ahead and do it the right way, you don't have to do that, right? So once you've got it installed, you can launch R again, and it'll ask you if you want to be a good open source citizen and send crash reports if they occur. I haven't seen a crash report in RStudio in a very long time. But you can see there, the thing on the left side of that screen is what happens when you start up R. So it basically shows you the command prompt. So that console is literally like running a console application. You also have the ability inside of this environment to do install packages and then go through and search for a particular package. And one of the things that you'll notice, though, is if you do, you can't see it on the screen, I'll show it to you in a moment, it actually just generates the code and pastes it into this window for you. So it's like packages or install.packages and then ggplot2, and that's what all this that comes back is, right? So we'll show that in a little bit. Linux installation, if we have time, I'll probably do that. It would help me probably to know if any of you are using Linux. If you are, do let me know. I'll be glad to help and go through this and put more of a focus on it. But the basic idea, go to the URL that's on that, so cloud-r-project.org/index, and then depending upon your operating system, what flavor of Linux you're running, you'll do an apt install r-base, and then you'll do some the CRAN repositories there at add apt repositories, and then do a sudo apt update and sudo install the appropriate GUI for your operating system. So also for Anacondas, it's kind of a similar thing. You go to Anaconda Products and say that you want the Linux version. You'll copy that address because it's basically a bash script, and then you'll run that inside of your local machine. So I've talked for a while, so let's do something, right? So at this point, it's actually created the other environment. Or is it still doing it? It's still doing it. So while it's doing that, we'll go ahead and download R and then RStudio. So we're going to go ahead and get R for Windows because this is on Windows. And we'll do R for the first time. And then we'll say download R 4.1. So whatever the latest version is. And it goes and downloads it. And then once it finishes, you'll launch it. Maybe really launch it. What did I click? I clicked the wrong thing. Maybe it already did it. Let me see. Go out to a command shell. Go to downloads. Let's see if R, so it doesn't know R, so we'll go ahead and run it. There we go. So it's saying select your language, English, next, 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 next. And it's literally, that's all it is. There's no real customizations that are necessary for this because you're probably not going to do anything terribly interesting. So at this point we're going and actually installing R. While it's doing that, we'll go ahead and tee up RStudio. So go similar process. You'll go to rstudio.com. You'll want to look for the individual version, so R Desktop. Again, if you're wanting money, that's the wrong thing. So you want RStudio Desktop. This is for open source, perfectly fine for educational purposes. It's going to say, first of all, go out and install R. And so if you're unlike me and actually read the screen, you would see that. I typically skip over things, and so I went straight to here the first time through. And you've also had the choice down here of it doing the installation of the various operating systems that you might be using that are not Windows. So switching back here, here it looks like it finished. Right, so kind of a funny thing, but let's go back out and see if R is there. Where did it put it? Anyway, we'll find it here in a moment. RStudio finished. We can go ahead and open it up, go through the process of launching it as well. Again, select the language, accept the license, pick where you want it to go. Installing R again, not RStudio. So that's where it is. So we go up there and cancel. Yes, so I already installed it. And RStudio popped behind for some reason. So accept the next on RStudio, and it's going to go through the process. While it's doing that, we'll go ahead and shift over to here and launch R so you can see it in process. And it's not all that pretty, right? But you're going to notice this is going to look a lot like what happens whenever you open up RStudio. This is literally R. R is I think it's data sets. Data, maybe. Here we go. So there are all the data packages that are kind of associated with R. Interestingly enough, it pops it up into a separate window here whenever it's actually in a console here. And you could actually say print hello world. And we just read our first R program, right? Q quits it. But you only need to know that if you're doing this at a command prompt and say, no, we don't want to save our state. So that is actually R. R is a very kind of older sort of thing. You can do something similar with Python, right? So we can say Python. That isn't going to work. I've got to be inside of a Jupyter environment because of environment variables. This one? Yeah. So here, Python. And it'll open up a similar sort of thing. This is a similar sort of environment. So print and it do the same thing. And I don't think it's, I'm trying to remember how you quit. I'll just do a Control C. It's exit. Yeah, there you go, exit. So, same sort of concept. You can run both of them at a command prompt if you're so inclined, or you can do it the easy way, which is use an IDE or an environment. So here is RStudio. Just finished installing. It's going to come up. First thing it's going to do is spawn off a process there. It's asking if you want to be a good corporate citizen or open source environment citizen. Say yes. And then you've got it. You're into R, right? And you'll notice that's the exact same screen that we saw before. The difference here, though, is you have the ability to do things like jobs. I'm trying to get through a firewall for some reason. And so on. And you can actually also do something here like create a R script. And this is probably a good way, if you're going to actually work in this environment, a good way to do it. Because what you can say here is tell it to run this anytime you save it, right? And so we can basically say source on save and then save it, give it some sort of name, hello.r, and you can see it's sourced hello.r, and it should have printed it. Oh, I didn't do anything. So print some string. So all I did, whenever I ran that, all it did was set up a variable inside of the environment. And that's the other piece here, is you can actually see the variables over here. And then we can do it again and say save here. And it ran it, and here was the results. So that's, if you're going to do RStudio, pretty good way to do it. Not exactly the way I would recommend, because I'm a big notebook fan. So at that point, we've installed R and RStudio. At this point, this should have finished. If you do it the easy way, you just go into Anaconda Navigator, click on RStudio, and say you want to install it. It goes out and does the stuff for you. So definitely something you may want to consider. There's some other cool things inside of this that you may want to take a look at if you have time. We talked a bit about Jupyter already. You can launch them from here as well. Orange, pretty cool too. Orange 3 is basically a GUI sort of environment that allows you to do data science, drag and drop, and clicking things together. You can do a lot of stuff that way. You can't do everything, but you can do a lot. So pretty cool, definitely worth looking at. Jupyter Labs is kind of the next generation of Jupyter notebooks. Something you may want to take a look as well. Spider is in a similar sort of thing. It's an IDE for editing Python as well. And obviously PyCharm, another sort of environment. So it's up to you. I'm not going to specify what sort of environment you want to use. Those are the choices that are kind of available to you. So at this point, we can switch back. We have talked about pretty much the first bit, except for I didn't show you how to install it in Linux, but probably most people aren't running Linux. If you are, let me know. So deliverable 1. So the scenario, this is all in your course room as well, is basically you're essentially a consultant of sorts in doing data science work. And so in order to do that, you need an environment. So that's what this is all about. So you want to create an environment. Your instructions is to install and demonstrate that you can set up a Jupyter notebook doing Python programming. You want to be able to execute, at very least, Hello World, which I showed you in several ways. But that's just the very baseline. It's not going to be good enough for you, most likely. You want to probably do a whole lot better. Then install and demonstrate the application of RStudio. And doing something a bit more interesting than Hello World as well there. And then do some graphs using ggplot, lattice, and also in Python, make sure you can show how to do NumPy, pandas, and do some work in that. And I have some interesting ideas that you may want to consider. The rubric, I showed it to you before. This is perhaps a little easier to see. So you want to shoot over here this rightmost column, right? You want to show me successful installation of R and RStudio with a significantly more advanced program for R. You want to show me Python, similar sort of concept with something more complex than Fahrenheit to Celsius. You want to show me something doing some graphs in both environments, or I'm sorry, graphs in R, and doing some NumPy and Matplotlib, I guess it is a graph, in Python as well. So that is the stuff that's necessary for deliverable 1. So with that, I've shown you quite a bit of stuff. Whenever you do the installation, it's going to ask you for an environment to put it into. Go ahead and create a new one, say R Studio. And that's probably a good start for the first discussion. With that, we'll switch to the obligatory question slide. My plan for our next meeting, which will be on Monday, is to talk about kind of the second part of that, doing some examples of the programs. I've got some pretty good ideas on what we want to do there to kind of get you thinking about something more complex than Fahrenheit to Celsius, because it's basically just a formula, right? So we'll look at something a little more interesting than that and start down the process of learning a whole lot more about this environment. So with that, I'm going to wrap things up. Thank you for watching. If you have questions, let me know. Stay safe, and I'll talk with you soon.